Let's talk about isomerism. What is isomerism? But before we go on, just giving you an overview, we will learn about structural and stereoisomorphism. 所以这是有两个不同的 isomerism. So we've got, as mentioned, 我们的 stereoisomerism. 它 will branch into optical and geometrical. 还有我们的 structure will go to chain, positional, and functional. We'll learn about structural first. It will be easier. Okay, so let's have a look. But before we move on, what is isomerism? Isomerism is when the compound have the same number of molecular formula, but different arrangement, even if order or arrangement. Okay, so let's have a look what I mean. For example, CH10, 这里是我们可能会看到的 CH10, but 我只要把它 rearrange, 看到吗？它也是有 CH10 在这里，只是我是不同的 rearrangement. Okay, so that results into one isomerism. Let's break down into details. First, we have chain isomerism. With the chain isomerism, 它其实就是讲这 carbon chain has been rearranged into different structure. For example, pentane 它可以换成 methyl butane and methyl propane, as long as the chain structure of the carbon is different. So 我们这里是 linear, 这里很像一个一个 T shape junction at this place, 然后这里是我们的 plus sign shape. So you can see 它们的 molecular formula are all the same, but 它们的 structure of the chain is different. And you realize that it's always CH2, CH3. Same goes here, CH3, 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 and CH3. And it's also the same here. 它们只是把那个 C 的那个部分换走而已。So, in your own time, try and draw as many isomers you can for your hexane. Now, with the positional isomerism, it's going to be an interesting one. 它就讲着我们的 functional group changes position. For example, 我们一开始我们这里的 OH 是右边的，然后我把它 change position， 看到吗？我这里的 structure 是一模一样的。But 我只要把它 change 那个 position， 我把它换过来这一边 ，OK， then that's what we call positional isomerism， 或者是换去of course 还有一个东西就是 up 它这里有一个不同的地方，就是也是 down up down up，OK， 然后这里是 down up，这里是 up down up down up， 我这里 down up down up down， 可是它也是 positional isomerism， 因为它有换了我们的 functional group 的 position。So technically speaking, yeah, it's not 我们刚刚的那个，它只能是 positional isomerism because it didn't change the carbon the structure， 它只是那个 up down up down， 记得 up down 和 up down up down 和 down up 是一样的东西来的，它只是为了给我们知道 there exists one carbon there. So try and practice this question. How many isomers are there of an alcohol with the formula of C5H11OH? But also one thing, now include with chain and positional isomerism. Okay, so both at the same time. And if you're feeling confident, it should appear. Do the extension here. Good luck with that. 这个确实有点 Okay, but have a go at this question. Now, with the functional group isomerism, it's not the positional, but it's functional group. What do I mean by that? 它就是讲是我们的 molecular are the same but different function group. So in this case, 我们的 function group is OH, but in this case it will be different. Okay, so you can see that our functional group here is O, but 我们的 molecular formula 是一样的。这里是 OH， 看到吗？ So that's what we call a functional group isomerism. So try and draw all of the isomers of C5H10 and have a look at which two are chain isomers and which two are positional isomers. And remember, double bond is a type of functional group. 看到这一边，你以为应该是学完了啦 but not technically. we still got another one to cover. So please hold yourself. And of course, we've got some prior practice. Feel free to do this question and let me know what are the things that you struggle. Stereoisomerism. Now, this is a different branch. 在我们的 stereoisomerism， 它就是讲这 structure and arrangement of the atoms are the same。这个是 arrangement 也是一样 ，but 它在哪里不一样？是我们的 3D dimension， 3D space not 3D dimension. That's literally repetition。然后我们就会 branch into geometrical isomers and optical isomers。With the geometrical isomers， 我们会讲，就讲到关于它的那个 cis trans 之类的东西。Okay, which there's a tip for you at the end of the next slide. So basically, with this, there's a free rotational possible with one sigma bond. 就讲在这里有一个 sigma bond， 我就可以做一个 one free rotation。But 如果这里是 sigma one single sigma bond 啦，可是因为这里是 double bonding， 所以 rotation are restricted。所以看到吗？他想要就是把这一个换过来 ，OK， but it's quite restricted. So I can only change CL and H and CL and H here. I cannot change CL and CL, H and H. Okay, so in this case, that's what we call isometric isomer. Okay. Now, in order to remember what cis and trans is, just remember cis, the word C is also doing the shape of C, and trans is taking the T top, like the line of T, 就是它的那个横线的 T, and then this kind of like across it. Okay, so in terms of origin of the word, cis is basically on this side, 然后 trans is basically across. So that's the reason why 它确实是有这一些名字的。Try and do some question here. Identify the cis-trans isomers and have a go at this question. 有什么问题随时跟我讲。I know it's going to be challenging for this one, but try your best. Now, with the optical isomers, what does it mean? So it will contain a chirocarbon atom. Huh? I mean, 这个是我们的那个that chemistry definition now. So let's have a look. Chiro or asymmetrical carbon is a carbon atom with attached of 4 different groups. 所以看到吗？就是有4个，它这是有要求的，它一定要是4个的。Okay, and it's non-superimposable in mirror image. Okay, what does that mean? 所以我教你一招。Okay, which the next slide will also do so. Basically, you put a mirror in the middle, and then 它 will reflect out. Basically, that's it. 所以 H3C 变成 CH3，OH 变成 HO， and etc. 这个叫做我们的 optical isomerism。如果是 mathematically, you can just say that is a reflection. So please， 如果你忘记什么是这个 non-superimposable image 的时候，或者是 chiro 的时候 ，use 2 of your hands. OK， 然后你就讲this is what we call mirroring. Okay, so that's one tip that we can kind of like make use of it. And so we can see 我们的这个那个 circles 的那些 model， 我们其实可以 form into 这一个 optical isomers. So identify the optical isomers here on your own time. Okay, feel free to let me know if you're struggling. And also sometimes 在我们这里的地方，它其实是很难去看到我们的这一个 chiral center 的。Okay, so we can see that these two, except for the bonding part, 它其实是 quite identical 的。Okay, but 如果我是去把它看到 into a 3D model, okay, you can actually see that it's actually differing. Okay, so we actually can see 2 different optical isomers. Okay, so they are not the same. Okay, 就是它们的 direction 之类的东西它是不一样的。So in your own time, I want you to identify where are the two chiral centers in this molecule. Have a go at this question. And also, feel free to do the chiral center in this case. Now, that's pretty much it for our paper, for our introduction of organic chemistry. Well done. Okay, so these are the past paper, and we have our end of unit recent exam paper. So please have a go at this question.